One of the issues that can come up when you're dealing with technology that is older and dealing with technology that is newer is trying to find a way to make those two things fit. Dr. Don Russell is joining us now from the Department of Electrical and Computer Engineering. Thank you for being here. Really appreciate your time today. Power lines and the power grid, years ago that all of this was set up. And I have a feeling that there are probably people who are thinking smart technology in different ways that you can just tell when a power line is going to go out. It doesn't quite work that way, does it?
Doesn't work that way. You know, we've been delivering power over lines in the backyards for way over 100 years. Mm-hmm. We're not doing it much different today than we were 100 years ago. Reality is that the basic concept of how power is delivered has stayed the same. Mm-hmm. Now there have been improvements, obviously.
Sure.
But we still basically do the following. We operate it, it breaks, we find where it broke, we fix it, and we operate.
Right.
So everything's reactive to
right.
the break, to the outage, to the poles down on the ground. Here we've been looking for the last couple of decades at ways to find things and fix them before they break and cause you an outage. So
which sounds fantastic.
It does work
mm-hmm.
in many cases, that we can predict the way an outage is going to occur, tell an operator to go fix this thing, mm-hmm. he does it, and you never have the outage, and you never know you had a problem.
Which is
the
wonderful.
Holy Grail for this.
Absolutely. Now, what is it called?
Distribution fault anticipation, meaning we call it DFA for short.
Sure.
The technology owned by Enium, developed here in our lab.
Mm-hmm.
It's a technology that basically uses a lot of very sophisticated computing capabilities that we have today that we didn't have even 20 years ago.
Right.
Knowledge-based systems, expert systems, things that allow us to in real time analyze the power system and say, ooh, I think this doesn't look right. We're going to go see that, and we find a breaking thing. Mm-hmm. Hadn't broken yet.
Right.
But it's in the process of breaking.
Well, and I was reading something earlier today. This can even go as far as a tree limb touching a power line somewhere.
That's right. Vegetation contact with power systems is a real problem. Most people don't know that your utility and every utility in the United States spends more money on trimming vegetation than they do any other repair of their distribution system.
Seriously?
Seriously. That's the thing that causes the most problems. And we can detect, in many cases, vegetation intrusion that's going to eventually cause a problem mm-hmm. and get people out there to do something about it.
That is terrific. And one of the other things that I read talked about wildfires, and that is our country right now is under such a horrible time, and this time of year, almost every year, is like this. I know that this is a fault within my own personal system, but when I think of wildfires, I'm thinking of human error. Somebody didn't put out their campfire. Somebody threw a cigarette butt out of the car. Honestly, never occurred to me that it could be a spark from power lines.
Yes. Human activity is probably the single biggest cause of wildfires, but a very substantial number, some of the largest in recent years in the United States, were caused by power line related matters. In our own state, the Bastrop fires were ignited by power lines, even though it was trees and other things causing those lines to come down. Mm-hmm. The actual ignition thing, the match, mm-hmm. was a power line. So to the extent that we can make the system more reliable and safer, we are also preventing some of the things that will cause wildfires. Today, I looked it up, there's 93 wildfires today in the United States.
Goodness.
93 right now, today, as we're sitting here burning.
Grief.
And some of those will have been caused by power lines, and some of those could be prevented with the technology that we've developed.
So how is the technology being used? Are you having a lot of power companies who are getting on board with this and saying, sign us up, we want to fix it?
The good news is that the state had enough foresight several years ago to fund, through the Texas A&M Engineering Experiment Station, a project to take our technology and apply it to this wildfire problem, and we did that, and we've just completed that recently. So we now know that we can prevent some of these, and we have roughly a dozen utilities who are letting us put some systems out on their distribution circuits to demonstrate how this will work. So the next step then is, now that we've proved it up, getting utilities to actually use it.
Right, right. So that's where we're headed at this point. But we know it works.
We know it works. We have testimonials from quite a number of utilities who've tried this out over the last 5 years, who say, we're not sure what we did without this before. Meaning,
wow,
on those circuits they've tried it, it gives them incredible improvements in reliability and safety.
That's got to be pretty thrilling for you and your team, having worked on it for so long.
It's good to see something that you do in a laboratory get applied in a way that's going to help the public. It's going to save lives, it's going to save property, it's going to do a good thing.
That's got to be just the best feeling. Engineering.tamu.edu, so much wonderful stuff going on in the College of Engineering, all the different fields and disciplines. Check it out, find out what's going on. Really, really amazing people doing amazing things. Dr. Russell, thank you for being with us today.
Glad to be here.
Appreciate it. We'll be back.